Today we'll continue to talk about distributed primitives. Last time we finished here, so I will get started from here. Continue to talk about one of the important API, distributed API, called request dispatcher. Similar to its counterpart. Do you still remember that? The counterpart of a request dispatcher, notification dispatcher. In my system, in GridFree, there are two types of message. The first one is the message is request notification. Notification. That's the first type of message. Another message request and response. So we talked about notification dispatcher last time. Notification dispatcher is responsible for managing the threads that process incoming notifications. So similar to that, request dispatcher is used to manage the incoming request. But different from notification dispatcher, the threads managed by request dispatcher is also used to generate corresponding response for each request. So that's a difference between them. So, but the internal implementation of the same, just one different. So that means the request dispatcher should manage the threads and that process the message concurrently, and also it must include the input-output stream based on network, so that data can be transmitted from the server side to the client side. This is actually is a TCP protocol embedded in the component or in the API. So there is some TCP protocol implementation inside it. So, but if you program this request dispatcher, you don't need to worry about the details TCP programming. You just use the mature API and use some patterns. Later I will explain the patterns. So just use such a simplified, encapsulate techniques to program the system that can process request and response. This is the explanation here. This is a thread pool, right? Because notification dispatcher is a thread pool. So similar to that, its counterpart, request dispatcher, is also request thread pool to manage a thread. Request dispatcher, the class looks a little bit complicated because different from notification dispatcher, it need to generate response. So response should be one of the placeholder for the class. Another placeholder is a stream. Stream I just mentioned here, right? Because I need to generate a response and send a response through the TCP protocol connection. So here, stream is used to send the response to the client. Nope, the parent class is a concurrent dispatcher, but you don't need to worry about such details. Let's take a look at implementation of. Just give you a look, but you don't need to. If you are interested, I don't need to explain that in detail. But if you are interested, you can if you are interested, you can also even modify the code, right? This is the implementation of request dispatcher here. Some detailed implementation. If you are interested, you're welcome to modify it. Here is how to use it. Request dispatcher, right? Request dispatcher is here. This is request. This is the first placeholder. This is a stream. We'll talk about those API later. This is response. This is response. This is a thread that process the request and generate the response. This is a thread creator, because the request dispatcher is the thread pool. So it need to know how to create such a instance of such thread when all the existing threads are busy. Let's continue here. This is a constructor, some parameters. This parameter is similar to the one of notification dispatcher, so I don't need to spend much time on the parameters here, because I want to show you the code to understand this entire system. You need to have a overview about the entire system, and if you want to know some details, you can investigate, do some research on those parameters. But I think if you are experienced engineer or developers, you can understand those parameters easily. Yeah. So I think I don't need to. I just gave you some general introduction in the previous classes. So this time, I want to go fast, so don't need to spend much time here. So because a lot of parameters, so I use the build pattern to simplify, so clean the code. This is how we can create an instance of a request dispatcher. Some parameters I use here, and all the parameters as constants. I use constants. If you want to modify it, you can update the constants. But before you can learn how to program it, you just use these constants. I just use the default value. In the near future, I will in the later classes, I will explain how to create how to set up these parameters using some configuration files. Then it's easy for you to adjust the performance of the system. It's a dispose, right? Some methods are here. Dispose, we need to, if the system shut down, the server must be stopped, and the concurrency mechanism, all the threads, all the computing resources consumed by the server should be collected. So this is the dispose. Is ready. This is similar. This is a lazy initialization. Idle checker is a similar to what I have done before, right? This way, because we need to check whether some thread managed by the thread pool, we need to know the monitor the states of the thread managed. So for the different system, the idle check period may be different. So if you want to change the parameter, you can do using this method. Okay, check idle and enqueue. So all the requests are put into the request dispatcher, and all the messages are scheduled by the request dispatcher. Wrong, because request dispatcher itself is also a thread. It should be managed by the server dispatcher. That's also similar to notification dispatcher. This is all the methods. We can take a look at the real code. Here, it's ready, whether this request dispatcher is ready. If it's not ready, it should be executed, because the request dispatcher itself is also the thread. So here there is a wrong method here. So so we can execute it like a thread. So that's why we can execute it, because it's a thread. We through this code, it's a thread, right? After the computing resources after the request are ready, we can put all the requests receive incoming requests into the request dispatcher. Here you can see the stream. Stream contains not only the TCP protocol output stream, but also contain the message. So you need to know, but we haven't talked about this API. It's a simple API. You just follow this this format, this design patterns to program your code. So different. This is a little bit different from here. When we process the notification, the code is simple. Just put enqueue the notification into the notification dispatcher. But here, not only the message, but also the output stream should be enqueued. And in addition, a log should also be enqueued, because the log should be manage the output operations. There are multiple operations to send the message to the client. So the operation, all the operations should form for a method. This method should be atomic, right? That's why there is a lock here. But you don't need to know so much detail. You just follow these design patterns. I will show how to create a code later. Okay, this is a brief introduction about the request dispatcher. Notification queue. Notification queue is the thread that process incoming notification. It's managed by the notification dispatcher. You can see here, right? This is the chat thread. Chat thread is the thread that process incoming notification. Here, this is notification queue. The chat thread is should extend or derive the notification queue. In other words, notification queue is the parent of chat thread. So the notification queue is all the threads, the parent of all the threads that process incoming notification. It's managed by the notification queue. This is the class. The class is also implemented in a way of generic. If one particular notification should be processed by a thread, then the notification, this notification, specific notification should replace this placeholder. This class has a parent. Its parent is called disposer runner. You don't need to worry about that too much. You just this is invisible to you, so you don't need to worry about that. We can take a look at here. This threads. Open it, right? You can see chat threads should extend notification queue. Notification queue is the parent, and this is the message to be processed by the threads. You can see here these are some code. This is the first time for you to see this code. But this code if you first time to take a look at the code, you must see the code a little bit difficult. However, this is the design pattern. I will talk about design pattern later. Although you think there's some, when you initially see it, you see it must be difficult. Actually, it's simple, because every notification queue implementation look the same. They are identical. This is identical structure. That's why I call it design pattern. So almost each all the notification queue are implemented the same way. The most important feature here is a to while, right? There are to while here. So I will explain and show that how to program the code later. It should be very, very easy. In the later classes, I will show you how to program with such a design pattern. And after that, I will also show you how we can all the code, even the pattern is simple. In the later classes, you can see we can leave the code. We don't need to. This code can be hidden to us. You can be concealed. You don't need to worry about that in the later class if you need. Yeah. So because we are talking about some the very fundamental APIs at this time, so maybe you can see some complete code, a little bit complete. Actually, it's not so not complete. It's simple because the structure is stable. So you don't need to worry about here, right? Constructor. This constructor is simple, just one parameter. It's called task size because this notification queue. Inside notification queue, there is a queue. All the message are enqueued and put into this queue and wait to be processed. But this queue have a fixed size, so we call it when the notification is initialized, we should set up this parameter. Oh, there are a lot of methods, right? Because this one, we need to use those methods to process the notification. And dispose, get key. Each notification queue have a key, but this key really is accessed by the notification dispatcher. So each queue, this thread is managed by notification dispatcher. So the key is required. Enqueue, the notification should be put into the notification queue that can be managed or processed. But this method is also accessed by the notification dispatcher. You don't need to worry about that. But this one is also get queue size is also managed by the notification dispatcher. Hold down. We should use hold down here. You can see here, hold down. Because there are two while loop here. The first while loop is like this, right? It's shut down. This one is shut down means this is shut down, right? The next method is shut down. It detects whether the notification queue is collected, is shut down. If it's shut down, then that means this thread should be collected, should be reclaimed, should be closed. If so, then the thread can be returned, right? So the run method can be returned. Here is empty. That what is in empty is empty detect whether there is a queue still exist in the queue. There is a notification exists in the queue. If so, it's not empty. If no message in the queue, then it's empty. If it's empty, then their while loop will be this code will be, the while loop will be terminated, and the hold down, we just mentioned hold down will be executed here. The hold down is important. If the queue is empty and if the thread is not shut down, then the queue, there is the CPU, if no hold down here, the CPU will be consumed by such a thread. The usage will reach the usage will be very high. So it's not good. It should not be allowed. So the hold down here is important. But when one message is available, the hold down is interrupted immediately. So you don't need to worry about whether the message can be processed instantly. You don't need to worry about that. So the hold down can be interrupted immediately if one message is received. So this is hold down, right? Is full. Is also this message. This message also measured by the notification dispatcher. It checked whether the notification, the queue of notification queue is full or not. If all the notification queue have a full queues, then maybe some new instance should be created. New instance of notification should be created, because that means all the threads are busy. So this method is used by the notification queue to manage all the threads. Is empty, we just talk about that. Is idle is also used by the notification queue. Notification dispatcher. Get notification is here. We should get the first notification from that's same as DQ. It's the same as DQ. Yeah. DQ. Today is February 19th. Peak notification. Peak notification is not used frequently. Maybe in some cases it should be used, but usually if we program with this pattern, this method is not used here. I remember, yeah, this method must be used by the also be notification dispatcher. I implemented this method, this system many years ago, so a couple of years ago. So I do not remember exactly why it should be used. But I think it doesn't matter. It's maybe it's useful, right? I don't worry about that. If you are interested, you can take a look at this. Right? Notification queue here. You can see all the code, all the low level code is here. Peak is I upgrade some the code here, so some new method is different, is created here. So you can see maybe some method I do not explain here. Peak notification. Oh, maybe it's not so useful. Don't worry about that. Okay. Dispose method. This is important because a lot of incoming message is received, and all the message should be collected, and because all the message occupy some memories, especially for the system that the volume of message is high. So after the message is processed, it should be disposed. You can see here that in the real code, the notification is disposed. Compared to, it's also this method, a lot of methods here are invoked by the notification dispatcher. Compared to is the same, is invoked in the same way. Developer just only need to, in most of time, developer just need to take a look at this code. They don't need to, all the method not in this code usually is are invoked by the notification dispatcher. This is compare to. Compare to is also used by notification dispatcher to compare the workload for each notification queue. That is important to schedule the scheduled workload for between, get load balance between all the threads managed by the notification dispatcher. Okay, so this code is this API is important. You may worry about that because it's maybe you have such question. It's a too low level because we still talk about some thread, right? You can see the name is thread. Yes, it's a low level because it's called distribute primitives. However, even it's looks a little bit low level. The code is easy to be programmed. I will show you how to do that. And although it's still a thread, or call it a thread, however, the thread is easy to be managed. You can see how to manage a program with more simplified techniques in the later classes. Because my sister is used to program any distributed system within the internet-oriented computing environment. I mentioned in the previous classes, such environment is very, very complicated. We need to deal with a lot of different scenarios, different complicated distributed cases. So thread should be visible. This is one of the important feature of GridFree. It's called IMTO, asynchronous messaging on the thread level. We talked about that before. So here, the thread is in the later classes, you can see all the thread is programmed in a similar approach. So, but if you program thread in such a way, that means that indicates that all threads are upgraded. All threads are not the native forms from Java. You are using notification queue rather than thread. I call such a thread is a messaging thread. Messaging thread rather than memory thread or message thread. Memory thread. I think Java thread is a memory thread. This is that is a low-level thread compared with my math thread. This thread is is easy to be managed and controlled. You just follow this design pattern to program thread. So they are easy to be implemented, to be managed, to be reused, to be monitored, to assign tasks. So you don't need to worry about a lot of details which should be taken care of by when you program with a native thread of Java SE, JSE, right? So I think because we need to, as I mentioned before, if thread is not visible, such a system is not generic for sure, because concurrency in different distributed systems, concurrency issues is different. We have to expose thread to developers such that developers can use their skills, to use their knowledge to implement the distributed system in their main. If thread is not visible, it's dangerous. The quality of the system is impossible to implement a high quality system. Request queue. Request queue is a counterpart of notification queue. That's very similar to the implementation of request notification queue. Different from notification queue, request request queue is used to process incoming request and generate a response and responding to clients. That's what request queue is. Why we need to implementation. We provide such a queue. Request queue is also thread. That's the same as the notification queue. Request queue is also important distributed primitive API. It's managed by notification dispatcher. This is the class. Because it needs to generate a response, so response is one of the placeholder. It also need to generate a stream, and then it used to send the response to the client, so it has a stream. That's also almost similar to the this placeholder is identical to request dispatcher. Dispose the runner, which I leave here. This is a constructor. It's just one parameter, task size. There's some method here. All the methods are same. Just here different. It's called get request, not get notification. Peek, dispose message. Here we have two dispose. Sometimes maybe you can use this one. Usually you use it, this one is fine. Collect the stream and collect response. Sometimes you can use, if you want to just dispose one, maybe the response is useful in some other cases. So you just want to dispose the request. So this method is called compared to respond. This is the one important difference between request queue and the notification queue. There is a method called respond. This method is invoked, the generated message response is sent from the server to the client. We can take a look at the real code here. Here, chat registry thread. We can open it. This is a request queue, right? Request response. There's a request. This response. This is a stream. Maybe here is some problem here, right? Because there are only three placeholder here. Request, response. The thread and the creator is not useful for this case. This is the one mistake. I just maybe copy paste something here. So this is one mistake. I just this is the problem, right? Only three parameters here. Three parameters: request, response, and the stream. Yeah. The format or the code structure of the request queue is also similar, almost identical here. Here you can see here, this is how we can process the request. After chat registry is received, maybe we create an account for it, create such an account, and save the account into a registry, and then we can generate response. So that's a different is here. We can make a comparison here, right? This is after those notification is processed, just a print on the screen, then we collect it. However, here, this is the method to process the incoming request, but different from the previous code. A response is created, and then it sent to the client response through the invoking the method response, and after that the message is disposed here. the request and the response. Usually we call this method to collect the string and the response together. Hold down, that's the same, right? The to while structure is also the same. Get request. So this is so when you program the thread in GRID3, the code structure is same. That means the pattern is same. The pattern is stable. So if this is the second time you see a thread, how we can program thread. Although this is the second time, you can see the code structure. The code structure is same. We will talk about the patterns through programming that. Then when I program the code, you can see I make a lot of operation of copy paste, and replace. I do a lot of such operation. You can see it's a CPR, a lot of CPR operation. That means the code structure is stable. So that's important. If the code structure is not stable, it's difficult for us to program using these such APIs. Constructor, the method. Okay. Next is alt message string. This is another distributed private API. We have seen this API in the previous discussion. It's used to send a message. First, it contains the incoming message request, and then it also contains the TCP output message, the output stream. So the response can be sent to the client from the server using this output message stream using this API. So we have seen that before, right? Here we can take a look at it again. Here, this is a one specific case implementation of such API. This is the output stream. If you want to implement the out message stream, you just do that in this way. You just follow this format. This code is very, very simple, right? You just extend, and when this is just a constructor, right? You just set up the parameter. So this API is very simple. This pattern is also simple. It almost can be generated by Eclipse, because I just used to implement the parent class and generate a corresponding constructor. So it's easy for you to program such API. Constructor, some method are here. Okay, no problem. Notification thread creatable. This is the interface. Because according to the name, you must know why we need to use it. It's used by the when this interface is implemented. That means you create a class that can be used to create an instance of notification queue. So here, this usually when the implementation, we call it a thread creator. This is one instance. You can see there is one implementation, right? They call it chat registry. Oh, not this one. This is a request. We can see another one, notification. This one, but they're same, almost the same. Right? Notification thread creatable. This is a placeholder, one placeholder. This is the threads. So if this pattern is very simple, just one message is required to be implemented. So you just tell the server, tell the request dispatcher, notification dispatcher, how to create one instance of notification queue. So this method is invoked by the notification dispatcher when a new instance of notification thread is needed. Another one is chat registry. Not this one. We have see it here. I can want to show you this one, right? This is the request. So this some tables to explain that is easy. Another one, the request thread creatable. This is also invoked by the request dispatcher to create the thread. The code is also simple, right? This so you don't need to spend much time to when you program the real system using such APIs. You just follow the instance, follow the sample code to create that, follow the pattern to create the implementation. Because you have never programmed this code, maybe you still do not understand why it's whether it's simple or not. Actually, it's simple, right? In the later classes, we'll talk about that. This is a class. It's a little bit difficult, different, complex than require a notification thread creatable, because it contains request, stream, response, and the thread. Method, just one method. Create request thread instance. Okay, here all the distributed perimeter APIs on the server side are finished. It's about, I really remember the total number of perimeter API is 13 total. This is a total one, and on the server side 9. We just finished all the 9 APIs of distributed perimeter APIs on the server side. In the later classes, we'll talk about 3 client perimeter APIs and 1 API that belong to both of them, either on the server side as well as the client side. In the later class, we'll talk about. We still have 4 APIs need to be discussed. Well, I hope I can finish these discussions as soon as possible, and then I can show how to program them. I think programming, if you are enjoy programming, programming is more interesting and it's funny, so we can implement what we want, and talking is not so interesting. Okay, we can do that step by step. Just 4 API need to be discussed, and then we'll discuss how to program with some mature code, mature design pattern, mature code structure. You can see it's very, very easy for you to use this code, to program this code, to program these APIs. Okay, that's all for today. Thank you so much.